Hello, let's look at the problem statement. Now, in the given problem statement, we are given an array of integers, nums, and we are given a target. We have to return two numbers such that the sum of the values of those at those indexes will sum up to target. Now, we can start by looking at the input. Let's just look at the first example. So let's take 2 and 7 and 11 and 15. And the target here is 9. So what we have to find out is what are the two numbers which sum to 9 and then return their indexes. One of the basic approaches for this could be the standard brute force approach. You select the first number and then you see if there is any other number that can get to this total. So we start by selecting 2 and then we check. Okay, does 7 and 2 equal 9? Yes, it does. And in that case, we're kind of okay. Now, this is the most elementary or the standard brute force solution. Choose the first element and then try to find any other element in the array that would get us to the sum of the target. So let's just write that down. Iterate through the array to find the next element that adds up to target. Now, consider a case when the input was in the opposite order. So let's say, oops, yeah, you have numbers in the opposite order where you have 15, 11, 7, and 2. And the target is 9 again. In this case, we start with 15. We check, does 11 and 15 add up to 9? No. 7, no. 2 and 15, no. Then we get rid of 15. We go with 11 again. We check 11 and 7, no. 11 and 2, no. Then we try 7. 7 and 2, we get the target. So we've got to try multiple operations. Now, as you can see, this is probably not the most efficient solution, but let's code this up first and then try to optimize this solution further. So, as we discussed, there are going to be two steps. The first step is choose the first element, and the next step will be iterate over the array and find the matching element. Now, as we've seen in the example, we're going to have to do this through a loop. So we will have to check for all elements. So we're going to use two for loops to code this up. So let me just take n, which is the length of the array, start an outer for loop to select the first element. So index I is going to be used to select the first element. Then we're going to have another inner for loop where we're going to use index j to select the second element, and we're going to check if nums I plus nums j equal to target. If it's equal to target, we're going to create the result array and add I and j to the result array and return the result array. If we come out of these for loops, that means there is no such pair, so we return null. So let's just try this. This should be I, and yeah, so this looks good. Traversing the array multiple times. We're starting with 15, trying everything after 15, then we're going to 11, then we're trying everything after 11, and so on. This is why because this is why the time complexity in this case is of O of n square. In the worst case, that is when the required target are the last two elements in the input or in the nums array, our time complexity goes up to O of n square because we're iterating over n elements n times. Now, in order to reduce time complexity from O of n square, there is a there are many methods you can use. In this case, what we're going to use is we're going to increase the space complexity. Currently, the space complexity is constant. We're going to reduce the time complexity to O of n, and we're going to increase the space complexity to O of n. What we're going to do is uh, keep the data in a map, and in the map we'll keep track of the value as well as the index at which it occurs. So next time we can just search for the element that we need to get the target sum. So we'll explain how to do this. Let me just write this down. So if we have the required element in the map, and if we do return it. Now let's just take an example. Assume we have the similar input array where we have, so we traverse the similar array, we have 5, 11, 7, 2. Let's say this is the input and the target is 9 again. In this case, what we can do is we can keep all of these values in a map. So let's say we have a map, we can keep it an entry. Now you look at the indexes. The index of 5 is 0 and the index of 7 is 1. So what we can do is store 5, 0. There's nothing else. 11, 1, 7, 2. And what we'll do is every time we check, so this is what the map is going to look like. Every time we iterate, we check, okay, now what's the target? The target here is 9 minus 5. So, sorry, 9 minus 5. Is 9 minus 5 in map when you are at 5? No, you move ahead. Is 9 minus 11 in map? That's minus 2. No, you move ahead. Is 9 minus 7 in map? No, you move ahead. Is 9 minus 2 in map? In that case, we do see 7 existing, and that's where we know we have an answer. So let's try to code this out. As you can see, this time we're only iterating through the array one time. That way we can reduce the time complexity from O of n square to O of n. Keep in mind, this is coming at the cost of increasing the space complexity. So let's code the optimal approach. We're going to create a hash map. And let's use n to get the size of the array. Once we have n, we just write a for loop and iterate through every element. We check if target minus nums I is present in map. If the map contains key target minus nums I, that means we have an answer. We create a new array, get the value from the map, and add I to the result array and return res. If we don't find this element, that means there is no solution, and in that case we should return null. So, and obviously if we don't see an element, we put the element in the map with the current index. I put the null in the wrong place. Let me just correct that. Okay, I'm not returning the rest in the if condition, so yeah, just add a return there. Yeah, that should take care of it. There. Thank you so much for watching. Have a wonderful day.